Hello all again. As you can see from the state of my workbench and the timestamps in some of these videos, it's been quite a while since I worked on this project. So I actually had to go back and look at some of the old videos to remember what I was going to do next. First order of business is I want to eliminate these two chips. They're unused, not needed for my new application. So, and an easy place to start, since I'm not fully sure what all over here was used and not used. Even here, I know this one's completely unused. I'm pretty sure I traced all this one out. But the only thing that I have drawn in the schematics I was working on is this one gate, which is pin 6. So, 2, 3, 4, 5, 6. Which is right there. So, these 3 pins here aren't connected to anything. So, gate 1's used, gate 2 is unused, but there's 3 and 4 which actually do go somewhere. So I need to look him up and just make sure that nothing else is going on in there. And nice picture of a cat. So that's a 7432. Oh, it's a plain 7432. And there it is. Crunch, crunch, crunch. Okay, so pins. Pin 8. Pin 8 looks like an output. Come on. Yeah, pin 8's an output. 8 and 11's an output. So the last 2 gates outputs go to these 2 resistors here, and they were memory bus enabled. So yep, these 2 are both totally not used, so I can make them disappear. So here we go for another fun adventure with the desoldering gun. Somewhere around here I had a I used to have a bag with all the parts that were coming off of the sign that I was just keeping things together. I've apparently totally lost it now. Is it on the table? Yep. Okay, so we've eliminated those. Next part that I said I was going to eliminate is this little op-amp circuit, which, looking back through my notes here, this was the pen input circuit. It looks like I did not draw that, so I think that's what I'm going to do next. So that's an LM10. I know I have a document for that guy somewhere. So that's what it looks like. So top view. So pin 1 is a voltage reference, pin 8. So let me just need a pen. So I'll just draw a quick cheat sheet of this part. So the tab is pin 8. It basically has 2 op amps in it. Seven, 6, 1, 2, 3, 4, 5. Where 4 is a voltage reference. Goes up to the plus input. 8 is the minus input. 1 is the output. 7's V plus. 6 is an output. 5 is balance. 4 is V minus. 2 and 3 are inputs. Plus and minus. Okay. So let's start with pin 7. That's voltage in. It looks to be the top pin in this orientation, which goes to one side of the ceramic cap. This side goes to this side, minus side of this cap. So I'm willing to bet that is the positive input rail. Where's an easy place to tap? I got a diode between that. I bet it's that diode right there. Maybe? Okay, I thought that was the positive power supply, but it's not. It doesn't beep out to anything, so I'm just sort of trying to follow it through and see where that actually goes. That pad right there, that shoots. Okay, that's the standby power circuit. There's the beep I'm looking for. So yes, that goes to standby power. Come on, pen. And 7654. So 7654. There's a bit of flux on these pins, so they're pretty hard to tell if there's a bridge between them or not. Not. 7654. 4 goes to that first resistor there. Bottom of that first resistor. I think that might just be regular ground. Yep, it just goes to ground. Nothing fancy there. I'm going to pop that guy off quick. It'll be easier to trace where everything goes. What this guy really did was, more than likely this was a voltage monitor circuit. So when the battery started to get low, it would issue reset to the processor. Or it watched the main power in, and when it got low, it either turned off or got low, it turned off the processor and put the memory in self-refresh so that the programs would be retained by the battery. Isn't that guy cute? By the battery power without putting a bunch of load for a processor and other devices on it. Okay, that should be easier. Way easier. Okay, so